Hello everyone, topic is Robinson annulation reaction. It is not involved in 12th class but as a doubt I am taking it. Reagents required are normal ketone reacts with alpha beta unsaturated ketones, in the presence of strong base will create six-membered cyclic alpha beta unsaturated ketone. Note down. Normal ketone, alpha beta unsaturated ketone in the presence of strong base will make cyclic, and how many carbons are involved? 6. 6-membered cyclic alpha beta unsaturated ketone. Let's check. First I am going to write them in general fashion. Ketone general formula is RCOR. Two alkyl groups are there. One alkyl group small, one is bigger. Both can be of same size also, but for the understanding of this concept, that's why intentionally I am writing one small, one bigger. And this is the general formula of alpha beta unsaturated ketone. Carbonyl group is there, this side alkyl group is there, that side also alkyl, but you can check around this carbonyl group, this carbon is alpha carbon, next is beta. Between alpha and beta we have unsaturation, means double bond. That's why we are calling it alpha beta unsaturated ketones. Now first in shortcut let me tell you how this reaction will happen. This small alkyl group will attack on beta carbon. This will be your first attack, obviously in the presence of base. After this attack, this alkyl group which is connected with alpha beta unsaturated carbonyl, this is going to attack on carbonyl of normal ketone. This will be second attack, obviously in the presence of base. After this attack you can count number of carbon atoms which are going to make a cyclic ring. Suppose this is first carbon, first will be connected with second, this one, second is connected with third, fourth, fifth, and fifth is connected with sixth. You can check all these 6 carbons will make a cyclic ring, and these side carbons will be on the side of the ring. This is the attack. Always small alkyl group will attack on beta carbon of alpha beta unsaturated ketone, and second attack will be from alkyl side of carbonyl of alpha beta unsaturated ketone on normal carbon of ketone. Now let's check for the reason. Let's go for the mechanism part. What is the role of base here? Now first of all, when I will say base, strong base, which base we have to use? We can use KOH, NaOH, sodium hydroxide, CH3CH2, O negative, Na positive, sodium ethoxide, or this one, potassium or sodium, potassium tert-butoxide. So what are base which attack on H positive? OH negatives have a tendency to attack on H positive. Here oxygen are also carrying a negative charge with extra lone pair, so they also have a tendency to attack on H positives. So that's why these two are also working as a base. So out of these 4, any base you can use. Suppose I am using KOH. Now KOH is going to provide me K positive, OH negative. This OH negative is looking for H positive. Who can provide H positive? Yes, normal ketone particles will provide H positive. For that, I am using one actual ketone, because from general formula the concept will not be clear. So I am using one actual ketone, this one. Intentionally I have made this side small alkyl group. You can check only one carbon, and this side bigger alkyl group. Now, do we have H positive? Yes, we have H positives. This hydrogen is connected with carbon. Carbon is more electronegative than hydrogen, so electrons are transferred toward carbon. That's it. That's why the hydrogen have positive charge. Same, this hydrogen have a positive charge. Positive charge. So these 3 hydrogens have a positive charge, can be attacked by OH negative. This side also hydrogens are available. Positive, positive. This side also hydrogens are available. But there is a problem on bigger alkyl group. What is the problem? Let's start from this carbon. Number one, these hydrogens are far away from the oxygen. That's why they are not feeling pull of electrons by this oxygen. Because this hydrogen positive charge on hydrogen is developed due to pull of electrons by carbon, which is also affected by oxygen, because oxygen we know is highly electronegative. It is attracting electron toward itself, and these hydrogens are close to the oxygen, so they are feeling more pull of electrons toward oxygen side. So don't you think these hydrogens have more positive charge as compared to these hydrogen? Yes, because these hydrogens are far away from the oxygen. Now, if I talk about these hydrogens, what is the problem? Watch. From this side, electrons are coming. This hydrogen is giving electron to carbon. This hydrogen is also giving electron to carbon. This hydrogen is also giving electron to carbon. So around this carbon, 3 pair of electrons are coming, due to which these electrons will be further pushed like this. Now, when these electrons will go toward carbon, don't you think these electrons which were coming from hydrogen side will feel some repulsion and they will move little back? This is the main point. When they will move little back, the positive charge of hydrogen will decrease. Same on this hydrogen also. These electrons will feel some repulsion and they will go back toward hydrogen. So the positive charge of hydrogen will be decreased. Means these hydrogens have a less positive charge because of distance from oxygen, and these hydrogens have a less positive charge due to backward movement of electrons, due to repulsion of electrons which are coming from this alkyl part. Such problem is not there in these hydrogens. These hydrogens do not have a problem of distance from oxygen. They are very close to the oxygen, as well as they do not have a backward movement of electron, which these hydrogens are feeling. Means out of these three type of hydrogens, type 1, type 2 and type 3, these hydrogens are highly positive. That's why they will be attacked by OH negative. This is the first point which we need to understand in Robinson annulation. That's it. OH is going to attack on hydrogen. So what will happen? Between hydrogen and carbon bond will break, and obviously electrons will completely shift toward carbon, because carbon is more electronegative than hydrogen. So what will be the next condition? Your ketone particle will turns to this, and what will release out? OH negative, H positive, H2O. This is carbonion, carboanion. Now this carbonion is getting stability through resonance. How? This is the negative charge which is creating instability there. This negative charge we can release or decrease with the help of resonance, movement of electron. If we shift this lone pair with this carbon, bond will generate here and pi electrons will get shifted toward oxygen. So the next resonating structure will be this. Those students who have a knowledge of resonance, they can understand it very easily. This one. Now this particle which is generated, we call it enolate ion. Enolate ion. Enolate ion. Negative particle. This one. So first understand the formation of enolate ion after the attack of OH negative on normal ketone molecule. Now, the carbonion which is generated on enolate ion on ketone, this carbonion is generated here. It's a negative particle, wants positive particle for the attack. Where we have positive particle? Yes, now alpha, beta, unsaturated ketones will come in role. This is alpha beta unsaturated ketone, this one. Now this carbon ion which is generated over here will attack on beta carbon, this one. This was alpha carbon, this is beta carbon. It will attack here. Reason? Let's check. For that, you need to understand resonating structure of this alpha beta unsaturated ketone. That I am going to draw. Keep it as it is. Wait. First we understand alpha beta unsaturated ketone and its resonance. This is alpha beta unsaturated ketone. How resonance will come here? Oxygen is most electronegative atom. So don't you think pi electrons will shift it toward oxygen? While movement, we know what is resonance, movement of a pi electron, that I am going to perform here. So the next structure will be this. Around this carbon, vacant orbital will be generated with a positive charge because its one electron has gone toward oxygen, a 3. This vacant orbital will be filled by neighboring pi electrons like this. So the third structure will be this carbon is losing its electron, this electron. So that's why now vacant orbital will generate on this carbon, plus one charge will there. And here double bond will be generated. This one. Now what will be the next movement? Repetition. Again oxygen will give electron to carbon and these pi electrons will shift back toward this carbon. So again repetition will happen. Now next time again. So the movement will be like this. Now due to this movement you can check positive charges arised on this carbon and on this carbon. Means these two carbons can be attacked by our carbanion. Which carbon it will prefer? It will prefer this carbon for attack, beta carbon. Reason is around this carbocation R group is present, alkyl group. And we know what is the nature of alkyl group. Alkyl group have a nature of donation of electron, which we call plus I effect. Due to this plus I effect, electrons are shifted toward carbon side. That's why its positive charge is decreased. Decreased positive charge. And why this plus I effect is enhanced? Due to oxygen, because oxygen is highly electronegative. It is trying to pull electrons toward itself, due to which these electrons are coming more closer toward this carbon. That's why its positive charge is decreased too much, which is not in the problem, which problem is not there with this carbocation, this one. Yes, R group is there. R group will transfer electron, plus I effect it is showing. But let me tell you, this R group is far away from the oxygen. That's why this plus I effect is very, very less as compared to the plus I effect of this R group. Means the positive charge of this carbon is decreased too much as compared to this carbon. Or in simple language, you can say this carbon is more positively charged as compared to this carbon. That's why carbanion is preferring to attack on this carbon. Let's go for the attack now. CS3, CH2, a carbanion was generated which is going to attack on, this is our group. We have CH, double bond, CH, CO, R, is going to attack on this carbon. Reason we have already discussed. Now when this will attack on this carbon, pi electrons will shift toward this and pi electrons will shift toward oxygen like this. This movement of electron will be there and the compounds are going to combine with each other. Please be careful and check check carefully. This R I am writing here now. These pi electrons are shifted there. Now double bond will come between these carbon and oxygen will have now negative charge and R. This one. This. Now, next, what will happen? In first step, H2O was released. Please check that. H2O was released. H2O, we know, will provide H positive and OH negative. This O negative will be satisfied by H positive. So, I am going to join it. So, here we will have OH. This condition in organic chemistry, we call it enol condition. OH, alcohol, and double bond. Enol condition. And enol condition is highly unstable condition because pi bonds and oxygen lone pairs are very close. Steric hindrance is there. So molecule rearrange itself. How? This is highly unstable enol condition. Check. Oxygen will break bond from hydrogen and will shift toward carbon like this, due to which there is a release of H positive. And when these electrons will come here, these pi electrons will shift on this carbon, due to which this carbon will become, I am going to write here, this carbon will become carbonyl, single bond will be here now. Here we have double bond with oxygen, R, and H positive which is released will combine on this carbon. So after this attack, our molecule will change to, here I am writing, reaction is quite complicated, so please be careful whatsoever I am writing. Don't miss any step. This is generated over here. Please check. This one. Please check whole mechanism. Now still reaction is not ended. This is a first step, first attack. Now second attack. I am going to write only that reagent which I required, this one. Now this R I have written here. Can I write CH2 and R here? No problem. To understand this concept, we require R group here. So R is made up of carbon and hydrogen. That's why I'm using it. Now in the presence of base OH negative, again OH negative will show its action. Here we have H positive particles. This one. These H positive particles, this one. This is acidic hydrogen, will get again attacked by OH and bond breakage will be there. This one. Electrons will shift toward carbon. Again a carbonyl will generate. CH3, CH2, CO, CH2, Cr, CH2, CO, CH, R, and this will become carbonyl. H2 will release out. Same like first step. Now this is a carbonyl. What it will do? Negative charge it is. It wants positive carbon. Where we have positive carbon? Here we have positive carbon. This one. This carbon is connected with oxygen, carbonyl group, negative, positive. Now here we have the main point of this reaction. This carbonyl is going to attack on this carbon, and you can check now 6 carbons will come in a cyclic condition. 1, 2, 3, 4, 5, 6. Please count again. 1, 2, 3, 4, 5, 6. And this reaction is known as intramolecular aldol condensation. In 12th class it is available. And the first reaction which we have done, in which ketone was attacked by base, carbonyl was generated, and that carbonyl has reacted on alpha beta unsaturated ketone, that we call Michael addition. So Robinson annulation is a combination of two reactions, Michael addition and followed by intramolecular aldol condensation. Now after this cyclic arrangement, let's check what will be generated. Now I am going to write this molecule in cyclic form. Okay, when carbonyl will attack on it, obviously pi electrons will shift toward oxygen like this. So the new condition will be, first I am going to write 6 carbons in cyclic ring like this. Suppose this is first carbon and I am going to draw it here like this carbon. This carbon is connected with this carbon. Let's assume it this one, this, and which is connected with R. So here we have R group. Next to it will be CO, means here we will have CO group. With CO, CH2, this is CH2 group. This is C, next C, this one, which is connected with R. Hydrogen you can adjust by yourself, and this is CH2, which will be this. Now, this carbon is also connected with, this first carbon is also connected with CH2, CH3, that I am going to write here. This you can check. Okay. O negative, again the same. O negative, H2O was released, it will give H positive, OH negative. So this H positive is going to combine on it. OH, CH2, CH3, R is there, H is there, O, H are there, R is there, H is there, H is there. Now the final step of the reaction. Watch carefully. Two steps we have done, Michael addition and intramolecular aldol condensation. And the last step is there, dehydration. This is the third step which will complete the reaction. Dehydration means loss of H2O. Loss of H2O. Look what will happen and where you have to lose, from where you have to lose H2O. This is carbonyl carbon. Between carbonyl carbon and OH group, this hydrogen and this OH. Check carefully. Carbonyl carbon, near to carbonyl carbon, hydrogen is there and OH will be there. So this OH and this H you have to release out as a H2O. And after this release, what will be generated? Obviously, this carbon will become unsatisfied. This carbon will become unsatisfied. And between oxygen and carbon, how bond will break? Electrons will go with oxygen. Between hydrogen and carbon, how electrons will shift? They will shift toward carbon. So this carbon will become carbonyl. And here vacant orbital will generate on this carbon. Lone pair, vacant orbital. They will make bond with each other to satisfy each other. And H2O will be released out. H positive, OH negative, H2 will be released out, and here rest part will remain as it is, no change. Now you can check. It's a 6-membered cyclic alpha beta unsaturated ketone, because this functional group is of ketone, which is alpha carbon, this is alpha carbon, this is beta carbon. Between alpha and beta there is a double bond, means unsaturation is there. So that's why we can call it cyclic alpha beta unsaturated ketone. Now let me tell you the reason of dehydration, because after dehydration This condition we are getting pi bond, double bond, and what is the use of this? Resonance. This molecule is stabilized through resonance. Check how resonance will come. Oxygen is more electronegative than carbon, so there is a movement of pi electrons. So at the place when they will go toward oxygen, at this place these pi electrons will come, means resonance. This molecule have a benefit of resonance. This molecule do not have a benefit of resonance. So to get more stability, means for making that compound which is more stabilized by resonance, there is a loss of H2O. Pi electrons and doubly bonded oxygens will come in a conjugation and resonatingly stabilized molecule will generate. That's why this molecule automatically losing water molecules and creating cyclic alpha beta unsaturated ketone. That's it. This is the end of the reaction. So now please check all the steps of the reaction. The first step was base attacked on normal ketone, carbonion was generated. That carbonion has reacted with alpha beta unsaturated ketone. That reaction is known as Michael addition. After that, another base has reacted with alpha beta unsaturated alkyl group. Carbonion was generated, and that carbonion has attacked on carbonyl group of ketone, which we call intramolecular aldol condensation. After that, we got cyclic condition, and that cyclic condition has stabilized itself better by the loss of H2O, and finally we are getting cyclic alpha beta unsaturated ketone. So it's a matter of practice. With a different molecules you can try that reaction. Thank you very much for watching the video.